Next question is derive the characteristic equation for the following flip-flop. First one is SR flip-flop, second one D flip-flop, third one T, and fourth one is JK, and it is from the question February 2021. Okay. So first, if we want to find out the characteristic equation, we have to draw the truth table and your characteristic table, right? Which gives the information about the inputs, the next state and the present state. So first one, let us start with the first one, that is your SR flip-flop. So SR flip-flop, what will be your truth table? Input will be SR, present state will be Q, and what is your next state? Okay. So what are the combinations? 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Right. So this will be your combination. Okay. So now when S and R is 0, 0, you have present state to be either 0 or 1. Similarly, S and R is equal to 0 and 1. You have two conditions. Either it can be Q can be 0 or 1. Similarly, when input is equal to 1, 0, either Q can be 0 or 1, and input is equal to 1, 1, Q can take the value 0 or 1. So what will be your first next state? That is for the first condition 0, 0. If S is equal to 0, R is equal to 0, there will be no change, right? So it remains the same. Okay. So this is your no change state. Now what will be your next condition? S is equal to 0, R is equal to 1. So S set is equal to 0 means Q will be equal to 0. Okay. So this will be the answer. Q is equal to 0 no matter what is the present state of your Q. Q is equal to 0 or 1, the output will remain in 0. What about your next one? 1, 0 means set is equal to 1 means Q is equal to 1. So your next state will be equal to 1. And the last one is what? Your race condition or your invalid condition. It is not defined in your SR flip-flop. So what are the values you have? So if I can take this as your so let us do it by means of K-map, okay, so that it will be easy for you. So if I construct a K-map with S, R and Q, 0, 0, 0, 1, 1, 1, 1, 0. 0 and 1. Okay. So for SRQ, 0, 0, 0, what is the value? 0. 0, 0, 1, what is the value? 1. 0, 1, 0, it is 0. 0, 1, 1, it is 0. Okay. 1, 1, 1, what is the value? Don't care. Then 1, 1, 1, sorry, 1, 1, 1, it is don't care, right? 1, 1, 0, it is again don't care. 1, 0, 0, it is 1. For 1, 0, 1 also it is 1. So how can we group? Can we group these four together, and this one we can group it in this way. Okay. So what will be your equation, characteristic equation? So Q plus is equal to, next state is equal to, Q plus is equal to. So first let us take the four groupings. So here this both get cancelled. So Q will get cancelled. So here it is 1, 1. 1, 0 will get cancelled. So 1, 1, what is the value? S. Okay. S is equal to 1. What is happening to the next? So here you have Q and here you have 0, 0, 1, 0. So 0, 1, first one will get cancelled, and 0, 0. So the R is equal to R dash. So your characteristic equation is equal to Q plus is equal to S plus Q into R dash. Okay. Now what about the second flip-flop? Second flip-flop is nothing but your D flip-flop. D or your delay flip-flop, right? D flip-flop, what will be your truth table? You have two options, right? So either your D, Q and Q plus. So what are the, either D will be equal to 0 or it will be equal to 1. So you have four conditions: 0, 0, 0, 1, 1, 0, 1, 1. So for D is equal to 0, you will be having Q can be 0 or 1. Similarly, D is equal to 1, Q can be either 0 or 1. So when D is equal to 0, delay flip-flop or data flip-flop means whatever is the input, that will be your next output, provided there will be a delay. Okay. So here you will be getting 0, 0. So here D is equal to 1. So the next state will be equal to 1. Okay. So in this case, D is equal to 0. So Q is equal to 0, and here you have Q is equal to 1. So this is a case of your D flip-flop. So D flip-flop, what will be your, by seeing this directly you can write the equation, right? So 1 1. So what will be your value? Q plus will be equal to, so you have D Q bar plus, or Q dash plus DQ. So in this, if I can take D as common, what will be your D dash plus, sorry, Q dash plus Q, which is equal to 1. So I can write that the next state is equal to D. Okay. So second one is done. Now your third one. So third one, what is your flip-flop? T flip-flop. So what is your truth table for your T flip-flop? Just similar to your D, you have two conditions, right? So what will be your option? 0 0 0 1 1 0 1 1. So when t is equal to 0, you can have your q as 0 or 1, and when t is equal to 1, you can have your q as 0 or 1. So what will be your next flip-flop? T is a toggle flip-flop. Whenever t is equal to 0, there will be no change. It remains in the same state. So present state is 0 1. So what will be your next state? Next state also will remain in the same condition. Now what about your, when t is equal to 1, what will happen? There will be a change in the state. It toggles. Okay, this is your toggle condition. So what will be, if it is 0, it will become 1. If it is 1, it will become 0. So what will be your characteristic equation? Q plus will be equal to, wherever you have 1, here you have t bar or t dash q, right? T dash q plus, here you have t q dash. So, or what is your expression? T plus is equal to T XOR Q. I can write it in this way. So this is your equation of your T flip-flop. Okay, third. Now fourth one, the last one is called as your JK flip-flop. So you know that JK flip-flop is nothing but your modification of your SR flip-flop. So how many conditions it has? So JK, it is similar to your S, K is similar to your R, right? Then you have your present state as Q and your next state as your Q plus. So what are the conditions? 0 0 0 0 0 1 0 1 0 1 0 0 1 0 1 1 1 0 1 1 1. Okay. When J and Q is equal to 0 0, you have two options. Similarly, when J 0 1 0 0 1 1, I have 0 1 1, right? Next you have 1 0 0 1 0 1 1 1 0 1 1 1. Okay. So when J is equal to 0 1, you have two options. Q can be 0 or 1. Similarly, when J and K is equal to 1 0, you have two options. Either Q can be 0 or 1. Similarly, it applies for your JK is equal to 1 1. So what is the only modification from that of your SR flip-flop? So this undefined condition will be defined here. It will be a toggle state. So let us take the first consideration. JK is equal to 0 0. What will be? There will be no change, right? This is your no change state. So what was your previous or your present state is 0 and 1. So what will be your next state? There will be no change. So it remains the same. What will be your next condition? When it is 0 1, J is equal to 0, K is equal to 1. So J is similar to your S, right? So S is equal to 0. So when J is equal to 0, K is equal to 1, you will be having it as your reset state. Because why? Q will be equal to 0. So your output is going to be equal to 0. Okay. Now when K is equal to 1 0, J is equal to 1, K is equal to 0. So it is your set state, right? So this is your set state. So Q is equal to 1. So your output will be equal to 1. Set means your output will be equal to 1. Now what happens in your, when JK is equal to 1 1, it is your toggle condition. So whatever is your present, the next state is going to be your opposite of it. If it is 0, it will be 1. If it is 1, it will be 0. So now can you construct a JK flip-flop? What is your we can proceed by using your K map. Okay. So J, K, Q 0 0 0 1 1 1 1 0. So what are the values you have got? 0 1. So 0 0 0, your value is 0 0 0 1, it is 1 0 1 0, it is 0, again it is 0 1 1 0 1 1 0, it is 1 1 1 1, it is 0 1 0 0, it is, where is your 1 0 0, it is 1, here also it is 1. Okay. So these are the values which you have got. So I can group these two together, right, and these two ones together. So what will be your q plus, your next characteristic equation will be equal to, so here it is q bar or q dash plus 1 0 will get cancelled, so you have j is equal to 1. So q dash j plus, what is the next value? Here it is q is equal to 1. So q into, here it is 0 0, here it is 1 0. So this 2 get cancelled, so it is k bar or k dash. Okay. So q plus is equal to q dash j plus q k dash. So this is going to be your characteristic equation of your JK flip-flop. So if I can make a table of everything together, okay. So flip-flop characteristic equation. So first is your SR, second one is your, what is the second one? D, T and JK. So SR, what is your value? You have got SR is equal to S plus Q R dash. For D, what is your value? D, your Q plus is equal to D. Q plus. What is your T? Q plus is equal to T XOR Q, right? T XOR Q, correct. Now for JK, what is your value? Q plus is equal to Q dash J plus Q K dash. Okay, so these are your characteristic equation for all the flip-flops.